So we're going to start by going over 4, and then we'll go over 13. It's really important that you can do 1 through 8 because, like I said, people forget about those and they miss those on the test. Okay? So let's talk about number 4 first and talk about the reasoning that you go through to answer these things. So on number 4, we've got a quadrilateral, and we're trying to decide if we can conclude that it's a parallelogram or not. So that's what we're trying to decide. Let's zoom in a little bit. Okay. So number 4 says RS is parallel to TU and RS is congruent to TU. So RS is parallel to TU and RS is congruent to TU. Now we had a checklist, and I gave it to you yesterday, of things that you can check for to see if a quadrilateral is a parallelogram. So on the checklist was both pairs of opposite sides congruent, both pairs of opposite sides parallel, both pairs of opposite angles congruent, diagonals bisect each other, both of them, and the last one on the list was one pair of opposite sides is congruent and parallel. That was the last thing on the little checklist that we went through. So I've got one pair of opposite sides, but they're both congruent and parallel. So yes, the answer is yes, it is a parallelogram. Ooh, there you go. Okay, so rewrite your last thing on your checklist. Do you want to go over anything else? Like, what about number 6? Let's just go over number 6 just so that you know how to solve these, because I want to make sure we're good at them. Number 6, Rx is congruent to XU, and Sx is congruent to XT. So you might think, oh, we've got congruent parts of diagonals, but be careful, the diagonals are not bisecting each other. Rx does not equal Xt, so the diagonals are not bisecting each other. So number 6, that would be an example of one that would be a no, because it's not following one of the things on that checklist. Okay? Okay, so you should have your family tree with you. It doesn't have all those pictures on it, that's fine. But we've got this right now, and we're going to add the bonus properties. So we already know the properties of a parallelogram. You can write it out in a full sentence. I'm just going to abbreviate for time's sake. But we know in a parallelogram, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are sup, and diagonals bisect each other. Okay, so that's parallelogram. Who discovered something extra about a rectangle? What's true? What's a bonus property of a rectangle? That's not one of those 5, that's extra. Diagonals congruent and all angles 90. Very good. So I'm going to put on here, I'm going to put 4 right angles. So put that with me. That's property number 1. And the other one is the diagonals are congruent. That is not true for a parallelogram. In a parallelogram, the diagonals are not the same length, but as soon as you go from slanted to up straight, the diagonals become congruent because a rectangle has good posture, standing up straight. What about a rhombus? What bonuses did a rhombus get? He's a parallelogram, but he's extra. What does he have? Good. Diagonals are perpendicular. I'm going to put that one last. Diagonals are perpendicular. All sides congruent. That's the definition of a rhombus. Good. All sides congruent. Good. The diagonals bisect the angles. They cut the angles in half. That doesn't happen in a parallelogram, and it doesn't happen in a rectangle. So the diagonals, that B with a circle means bisect, the diagonals bisect the angles. Okay, these are really important. It's really important to keep track of which properties go with rectangle and which properties go with rhombus. Then a square, let me give you a hint. Parallelogram, he's got 5. Rectangle has 2, so we're up to 7, and a rhombus has 3. So a square gets all 10 properties. So a square is a parallelogram that is a rectangle and a rhombus. If you're a parallelogram and you've got 4 right angles and you've got 4 congruent sides, then you're a square. So if you're a parallelogram with 4 right angles and 4 congruent sides, then you're a square. Okay, I'm going to leave this slide. The next thing I want to talk about is right here. I want to talk about this really quick. Here's how the family, the square gets everything. He's the envy of everybody. Here's how the family tree works. In this family tree, every shape is himself, and he's everything above him. So a rectangle is a rectangle and a parallelogram and a quadrilateral. A rectangle is a parallelogram and a quadrilateral. You are yourself and you're everything above you. So a square is a rhombus. Is a square a rhombus? Yes. Is a square a parallelogram? Yes. Is a square a quadrilateral? Yes. We'll do the true false. Let me give you an analogy because I just think it's kind of fun. Okay, so I want you to think of quadrilaterals. They're the human race. If you're human, you're a quadrilateral. Okay, so all humans are quadrilaterals. Stop typing the answers. Some humans are U.S. citizens. So some humans, some quadrilaterals are parallelograms if they're a U.S. citizen. Some U.S. citizens are over 35. And some U.S. citizens receive the majority of votes in an election. If you're human, you're a U.S. citizen, you're over 35, and you receive the majority of the votes in a presidential election, then you become the president. So, like on number 1, all squares are rectangles. That's like saying all presidents are over 35. Well, yeah, it's written in our Constitution, right? Or written in some document. I'm not your history teacher. But all presidents have to be over 35. So all squares are rectangles. A rectangle is a requirement to become a square. Okay? So that one's true. All squares are rectangles. Next one. Some rhombi are rectangles. Now that one's hard. Some rhombi are rectangles. What if a rhombus becomes a square? What if a rhombus is a square? Then is he a rectangle? Yeah. So most of the time a rhombus is not a rectangle. But if a rhombus is a square, then he is a rectangle. So I'm going to put true, and it's because of that word, some. Sometimes a rhombus becomes a square. And if he is a square, if he's the president, he's over 35. If he's a square, he's a rectangle. So I hope that one's okay. All parallelograms are rhombi. All U.S. citizens win an election. All of them do. No, that's crazy. All parallelograms are not rhombi, so false. Some rectangles are squares. Some people over the age of 35 become the president. Some of them. Some rectangles are squares. So I hope that always, sometimes, never, true, false stuff is going to be okay with you. Okay, now let's use our new properties to try some examples. I've got a couple examples, if you can just stay with me and then we'll be done. Given rhombus math, find the missing angle measures. So this is the angle you're given, and you're pretty much trying to find all the missing angles. So you need to rely on your family tree, rely on this for a while until you get to know it. One of the properties of a rhombus is that the diagonals are perpendicular. It's a property of a rhombus. So I know if this is a rhombus, then I can immediately do this, because that's one of his properties. It's one of his special traits. Good. Another property of a rhombus is that the diagonals bisect the angles. The diagonals bisect the angles. So I get to add something to my picture. Arc, 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 arc. Double arc, double arc, double arc, double arc. So that's how a rhombus works. The angles, the opposite angles are still congruent, but they also get cut in half. Two things happen. So I can start filling things in. 22, 22, 22, 22. Now we're going to have to use one of our rusty properties, one of our dusted off, our properties from yesterday. A rhombus is still a parallelogram, so he gets all the parallelogram properties. So in a rhombus, consecutive angles are still supplementary. So this one and this one, I just grabbed two of them, whichever ones I felt like. Those are still supplementary. So if angle H is 44, then angle M is... Oh, good, you already got it. It's 136. So this one, the whole angle is 44. So the whole angle is 136, but we are going to cut it in half because in a rhombus, the angles are bisected. So 68, 68, 68, 68. So in a rhombus, with the diagonals drawn, if you know one angle, you know all of them. I drew a lot on that picture. I hope we're okay. Let's move on. Rectangle rock. RK is 3. RC is 9. Find the perimeter. Oh, is it? Cool. So you're going to use one of your properties. You're always going to use your properties. One of your properties of a rectangle is that it's got 4 right angles. So let me just warn you now, in a rectangle, you're going to use Pythagorean theorem a lot. Because a rectangle, when you draw a diagonal, creates right triangles. So in a rectangle, you're going to use Pythagorean theorem a lot. Very good. 9 squared minus 3 squared. $72. That is not a perfect square. So are you factor treating 72? Should get 6 root 2. Can you check me on that? 6 root 2? Think I'm good? And now we need to find the perimeter. So 3 plus 3 is 6. And 6 root 2 plus 6 root 2 is 12 root 2. So there's the perimeter of rock. Now we're going to do the angles, and then we'll do a square, and then we'll be done. Okay, stay with me. I know it's a long day. Okay, let me just start talking about it. Measure of angle ROK. ROK, so this angle is 49. Now let me tell you what happens in a rectangle. Our diagonals are congruent. So they bisect each other and they're congruent. Do you know what that means? If they're the same length and they both get cut in half, then in a rectangle, boom, 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 boom. In a rectangle, you have 4 isosceles triangles. Isosceles triangle A is the same as isosceles triangle B, and then isosceles triangle C is the same as isosceles triangle D. So you've got 2 pairs of congruent isosceles triangles. So if this is an isosceles triangle, then the base angles are congruent, 49, 49. And then we can add them up, 49 plus 49 minus 180, and we get this angle is 82. Then we know a rectangle, hey, he's got 4 right angles. 4 right angles. So you just find the complement of 49. Because 90, you've got 90 degrees and you use up 49. So you've got 41. Then you can do alternate interior angles, 41, 41, 49, 49. And then you've got isosceles triangles, so the base angles are congruent, 49, 49, 41, 41, 41. Do you see how this is working? I know I'm going so fast. And then we can find the linear pair to 180. I'm just finding all the angles because why not? 98, 98, 82, 82. Same with a rectangle. If you know one of those angles, you can find all of the angles. It unlocks everything. So what I do need you to understand is that in a rectangle, you've got isosceles triangles, and you've got to use base angles to help you out. Okay, last thing. Square element O. Find the perimeter of L in O. Find the perimeter of this triangle. Hopefully, when you were playing with Sketchpad, you realized that that's a certain kind of triangle. And this is our last thing, I promise. You should have realized that, well, those angles are 90, and then they're also bisected, so that's a 45, 45, 90 triangle. So we've got 12, 12, 12, root 2. 12, 12, 12, root 2, 45, 45, 90. So the perimeter of L in O, 24 plus 12 root 2. I am done talking. I need y'all to definitely do your homework tonight because we do have a quiz tomorrow.